Hello students. Okay, we will start the lesson permutations and combinations again today also. And we'll do some more problems based on this. Let's copy the first question. Here is the first question. As per the first question, total number of words formed by 2 vowels and 3 consonants taken from 4 vowels and 5 consonants is, so total you have 4 vowels and 5 consonants total. But out of that, you have to take 2 vowels, 3 consonants, arrange them, jumble them, arrange them, and form as many words as possible. So first work is about vowels. Second work is about consonants, which you will multiply. So from 4 vowels, you will take 2 vowels and arrange. And then from 5 consonants, you will take 3 consonants and arrange. The 2 works you are multiplying according to fundamental principle of counting. So now 4P2, start from 4 into 3, take only 2 numbers, into 5P3, start from 5, 4, 3, take 3 numbers, 4 3 is 12, 3 is 36 times 5 into 4, 20. So 4 into 3, 12 times 3, 36 you have taken. And then left off 5 times 4 is 20. That means 36 times 2 is 72 and then 0. So 720, you can take option C. Just remove that printing mistake 10. 720 will be the answer. This many words can be formed, but not necessary that all will be meaningful. Okay, now next, second question. The number of different permutations of the word banana is, so if you take the letters of the word banana and arrange, total how many words can be formed? So we know that in banana, total 6 letters are there. If you count, 6 letters are there. But then you can also see that A is coming 3 times and N is coming 2 times. A 3 times, N 2 times. So when you take the number of arrangements, in the numerator, it will be 6 factorial total. And because A 3 times 3 factorial, N 2 times 2 factorial. So this you can simplify as 6 into 5 into 4 into 3, stop by putting factorial. 3 factorial into 2 factorial is 2 into 1. 3 factorial cancels, 2 2s, so 32s, 60. 60 number of different words can be formed when you jumble the letters of the word banana. Let us see the next question. Here is the next question. It says there are 4 bus lines between A and B and 3 bus lines between B and C. The number of ways a person round trip by bus from A to C by way of B will be. So, suppose this is A. From A to B, there are 4 buses. And from B to C, there are 3 buses. A person wants to go by bus from A to C. So this is fundamental principle of counting. First work can be done in 4 ways. He can go from A to B by 4 different roads. Second work, from B to C, he can go in 3 ways by 3 different roads. By fundamental principle of counting, you have to multiply 4 and 3. So total there are 12 ways by which the person can reach C from A. Okay. Next question. Here is question number 4. As per the question, in how many ways 5 red and 4 white balls be drawn from a bag containing 10 red and 8 white balls? Total, there are 10 red balls and 8 white balls. You are drawing them means you are selecting, you are not arranging. You are arranging 5 red and 4 white balls. So taking red balls is one work, taking white balls is another work. Yes, that's correct, Lohin. Did you say A? I don't think A is correct. Let's see. So the first work, from 10 red balls, yes, Lohit, B is correct. You have to select 5 red balls. First work over. Into, from 8 white balls, you have to select 4 white balls. So this is B. Option B is the correct one. Okay, next. Here. The number of diagonals that can be drawn by joining the vertices of an octagon. In octagon, total there are 8 vertices. When you want to make a diagonal, you have to select 2 vertices and join them. It's not arrangement. Suppose you are selecting this vertex A and this vertex B and joining the A and B vertices to form a diagonal. So AB is already a diagonal. What is the use of counting BA also as diagonal? Whether AB or BA, both the diagonals are same. So you need not take both. That means not arrangement. First A, first B, that doesn't matter when you are counting the diagonals. That's why I told it is selection, not arrangement. So from 8 vertices, you have to select 2 vertices to make diagonals. That means start from 8, 8 into 7, take only 2 numbers by 2 factorial. 2 ones, 2 fours. So 28 number of diagonals can be drawn in an octagon. Octagon means having 8 vertices, having 8 sides. Okay, let us copy. Next one. Ramesh has 6 friends. In how many ways can he invite one or more of them at a dinner? So, this kind of problem, there is a separate formula. So, out of 6 friends, he can invite one friend or more of them. But the thing is, he should not keep quiet and he can't sit and eat the whole dinner alone. He can't sit alone and eat the whole dinner. He has to invite friends. And how many friends? One friend or more friends. It depends. So what you have to do? You have to take 6 and you have to factorize. This is all about factorization. Or you can take directly 6 also. Either factorize or directly take 6 in the formula. What is that formula? 2 power n will give you have to invite friends. The formula is 2 power n to invite friends. That means he need not invite friends. If he wants, he will not invite friends. If he wants, he will invite one friend. If he wants, he will invite 2 or 3 or 4 or 5 or 6 or 0 also. He will not invite any friend. But here, 0 you can't take. So that one case you will subtract. Because he cannot invite 0 friends. He cannot sit and eat the whole dinner. That is why that 0 friends, one way we are subtracting. So now he has total 6 friends. So you will take 2 power 6 minus 1. 2 power 6 is 64 minus 1. That means there are 63 ways for Ramesh to invite friends. In that ways, he cannot invite 0 friends. He can invite 1 friend, 2 friends, 3 friends, or all 6 friends also he can invite. Nothing wrong in that. Okay. Next question. Total number of words formed by 2 vowels and 3 consonants taken from 4 vowels and 5 consonants. Almost this kind of sum we did already. Total, how many vowels are there? 4 vowels, 5 consonants. Making words means selecting and arranging both. Making words means arranging also will be there. Taking and arranging. So we can take arrangements. We have to take 2 vowels and 3 consonants. This is taking vowels is the first work. Taking consonants is the second work. So first work can be done in 4P2 ways. And second work can be done in 5P3 ways. 4P2 means start with 4, take 2 words, 2 letters, 4 and 3. Into start with 5, take 4 numbers. So 4 threes, yes, correct load. 4 threes 12 and 12 threes 36 times 5 fours 20. It is 720. It's again the same question, printing mistake. So you'll take C as the answer. Okay. Next question. In how many ways 5 prizes be distributed among 4 boys when every boy can take 1 or more prizes? So there are 4 boys standing in a line. There are 5 prizes. The first boy can get 1 prize or more prize. He can get 1 or 2 or 3 or 4 or all the 5 he can get it. So there are 5 ways to give prize. For the second boy also 5 ways. For the third boy also 5 ways. For the fourth boy also 5 ways are there. Because they all can have 1 or more prizes. But if you take like this, what happens? Already the first boy will get 1 prize. Suppose he will get 1 prize. Then for the second boy, what will happen? Only 4 prizes will be there. Suppose if the first boy gets 2 prizes, then for the second boy, only 3 options will be there. That's the problem if you take like this. So then what we have to do? We will take 5 prizes only. Instead of boys, we will take 5 prizes only. The first prize can be given to any one of the 4 boys. Again, the second prize you can give to any one of the 4 boys, because if the first boy is getting prize 1, he can get prize 2 also. He can get prize 3 also. The same boy can get all the prizes. So here, third prize, to give third prize also 4 boys are there. To give fourth prize, 4 boys are there. To give fifth prize, 4 boys are there. This is how you will take, and then multiplying all 4 power 5 ways you can give the prizes. 4 power 5 means 4 into 4 into 4 into 4 into 4. So this is 16, 16, 256 into 4, which is 1020. That's why whom you should make stand, the prizes or the boys, that you have to see. Okay, Lohit got the answer before itself. Very good. Okay, next. how many different committees of 5 people can be formed from 6 men and 4 women, on which exactly 3 men and 2 women serve? So you have to select 5 members total. But total what you have is 6 men and 4 women. And from this you have to select exactly 3 men and 2 women. So this is the first work, this is the second work. It's very easy problem. It is selecting, because we are not arranging them, we are selecting them for the committee. 6C3 first work into 4C2 second work. Now, to expand the first, start with 6, take 3 numbers by 3 factorial. Start with 4, take 2 numbers by 2 factorial. This will cancel and this will cancel. I will cancel these two at one time. That will be better. 6 and 6 I will cancel instead of cancelling 2 times. And then 2 2s like this. So I will have 20 into 6. That is 120. In 120 ways, the committee can be formed. Okay. Next. The number of words from the letters of the word Bharat in which P and H will never come together. P and H never come together. Suppose think that B and H come together and they are treated as one letter. What else you have? A, R, A, T. So now total, how many letters you have in the word? B and H is treated as 1. 1, 2, 3, 4, 5. So 5 factorial by A is coming 2 times. So 2 factorial. This is the way of arrangement. This is arrangement, remember. But B and H can arrange among themselves in 2 factorial ways. So this is the work. But now, if you won't see together or not together, no condition. Total you have 1, 2, 3, 4, 5, 6. 6 letters you are arranging. But among these, there are 2 A's. So 2 factorial. This is the number of arrangements on the whole Bharat word without any condition. This is total. This is B and H coming together. So if one says B and H not together, that means from 6 factorial by 2 factorial, you have to subtract 5 factorial. Now what is 6 factorial? 6 into 5 into 4 into 3 into 2, stop here by 2 factorial, minus 5 into 4 into 3 into 2 into 1. This you will subtract. So 2 factorial and 2 factorial will cancel. 5 into 4 into 3 you can take common. So left is 6 minus only 2 factorial is left. So 5 into 4, 20, 23, 60. You have to multiply with 4. Yes, Lohit, this is correct. So total 240 ways you have, which is option B. Okay, next. This is the next question. What is said in the next question? If a 5-digit number divisible by 3 is to be formed using the numbers 0, 1, 2, 3, 4, and 5 without repetition, then the total number of ways So how will you do this? If a 5-digit number divisible by 3 is to be formed using the numeral 0, 1, 2, 3, 4, 5 without repetition, then the total number of ways it can be done. So we will take 5 digits. 1, 2, 3, 4, 5. What are the numbers given for us? 0, 1, 2, 3, 4, 5. So total 6 numbers are given to us. But we have to form 5 digit. If you see the first place, except 0, you can take all other 5 numbers, and that can happen in 5 ways. Any 5 of the numbers can come and sit. Into, why did I not take 0? For the first place, I did not take 0. Because if I put 0 in the first place, it will not be 5-digit number, it will be 4-digit number. We don't want 4-digit number, we want 5-digit number. That's why I did not use 0. But when I take second place, already out of 6, 1 is occupied here. Out of 6 numbers given to us, 1 is occupied because repetition is not allowed. Now we have only 5 letters. Out of 6 letters, 1 went here. So first space can be filled in 5 ways. So out of these 6 numbers, now we have only 5 numbers left. Because 1 sat in the first place, 1 number. So the second place can be filled up in 5 ways. Into, now for the third place, already 2 numbers are taken out of 6 numbers because repetition is not allowed. So 2 numbers are taken means we have only 4 numbers left. So third place can be filled up in 4 ways. Fourth place, only 3 numbers are left. So we can fill it in 3 ways. Fifth place, only 2 numbers are left. So we can fill this blank in 2 ways. So Oh, fundamental principle of counting. 5 times 5, 25. 25 into 4, 100. Into 6, 600 ways. That's the answer. No Lohit, not 8, not A. It is C. Let's go to the next question. Here. If sides AB, BC, CA of triangle ABC have 3, 4, and 5 interior points respectively on them, then the total number of triangles that can be formed by using these points as vertices. So there is a triangle ABC. The side AB has 3 interior points on them. So these 3 points can be here, or the 3 points can be here. Similarly, the side BC has 4 points. The side CA has 5 points. So total we have how many points? 3 plus 4 plus 5. Total 12 points we have. To make a triangle, we need 3 points. We have to join 3 points. So you have to select, not arrange. From 12, you will select 3 points. But these 3 points should not be collinear. Collinear means like this: 1, 2, 3, 4, 5, 6, 7. No 3 points should be collinear. Did they talk anything about collinearity? Did they tell us 2 points or 3 points or 4 points or 5 points are collinear? Did they talk about that? No, they did not talk anything about collinearity. The points may be not collinear. But we have to, because they did not say, we have to take the condition. We have to see that the collinear points should not be taken. Remember that. Okay. So what will we get here? Start with 12. Take 3 numbers and divide by 3 factorial. So you will take 2. So how many you got? 220 triangles you got. But out of them, you have to subtract the collinear points cases. See whether they are collinear or not and remove them. So how many you will remove? How many you will subtract collinear points? From 3, if 3 are in collinear, you will not select. From 4, the 3 points which are in collinear, you will not select. From 5, the 3 points which are in collinear, we will not select. So all these points we will not select. That means how many points we are not selecting? Start with 3. Take 3 numbers by 3 factorial. Start with 4. Take 3 numbers by 3 factorial. Start with 5. Take 3 numbers by 3 factorial. So 3 factorial and 3 factorial will cancel 1. 6 and 6 will cancel 4. Then 3 twos and 2 twos. 5 twos, 10. So 15 collinear points cases we have to subtract. From 220, subtract where we are selecting 15 collinear points, 15 cases where collinear points are taken. And if you have 3 collinear points, you can't make a triangle. So those you will subtract. Yes, correct, Lohit. So the answer is option C. That is 205. 205. Okay, next. A student can take one of the 4 mathematics sections and one of the 5 English sections. The number n of ways he can register for the 2 courses is, so he has to register 2 courses, maths and English. In maths, total 4 sections, and in English, total 5 sections. So he has to select 2 courses. That means from 4 maths, he will select 1. Another work from 5 maths, he will select 5 English, he will select 1. So 4C1 is 4, 5C1 is 5. So he can select 2 courses, maths and English, is in 20 days. 13th option also, C, you can take. Okay, next question. Here is the next question. There are 10 lamps in a hall. Each one of them can be switched on independently. The number of ways in which the hall can be illuminated. That means you can have the lights in the hall. Total 10 lamps are there. To light up the room, out of 10 lamps, you can select 1, or you can select any 2, or you can select any 4, 5, 6, 7, 8, 9, 10. All 10 lamps also you can light up. They did not say how many lamps have to be lighted, but starting from 1. So from 10, you can select 1 lamp to light. The room will be lighted. Similarly, from 10, another work, 2 can be selected. From 10, 3 lamps can be selected. From 10, 4 lamps can be selected. From 10, all the 10 lamps can be selected. So in how many ways you can do so that you can keep the room lighted? Let us see. 10C1, 10C2, 10 into 9 by 2 factorial. 10 into 9 into 8 by 3 factorial. 10 into 9 into 8 into 7 by 4 factorial. Like that, you have to go on taking all these. But will you multiply or will you add? That is the main thing you have to notice. I will tell what you have to do. 10C4 is over. 10C5 will be same as 10C5 only. 10, 9, 8, 7, 6 by 5 factorial, 120. 10C6 will be same as 10C4, 10, 9, 8, 7 by 24. 10C7 will be same as 10C3, 10, 9, 8 by 6. And 10C8 will be same as 10C2. Lastly, 10C10 will be same as 10C0. This is 10C1, 10C2, 10C3, 10C4, 10C5, 10C6, 10C7, 10C8, 10C9 is same as 10C1. So 10 and just leave it. So here, if you see my sentence, one lamp can be lighted or two lamps can be lighted to light the room, or 3 or 4 or 5 or 6, or all the 10 lamps can be lighted. So here, different cases, or means addition and means multiplication. That you have to remember. So or means you have to add while telling the sentence. And means we have to multiply. So each of these 10 cases we will see. 10. So 2 5s, 5 9s, 45. Then 3 3s, 3 2s, 2 4s. So 120. Next, 8 1s, 8 3s, 3 3s. So 210. Next, 120 we have. 120 means 10 12s, 6 1s, 6 2s, and 2 4s. So here multiplication is difficult, but take some time. What you have to multiply? 9 4s, 36. You have to multiply by 7. So 252. That I will add. Then again 24. 8 3s, 3 3s. 21 times 10. 210. Then 2 4s, 2 3s, 3 3s. Again 120. 2 5s. So 45. And the last one, 10. So what you can see here in these options is 10 is coming here. 10 you are adding 2 times. Same way 45 you are adding 2 times. 120 you are adding 2 times. 210 you are adding 2 times. You can take them 2 times and add, or add 1 time and multiply by 2. And then finally you have to add 252 also. So 1022 ways. Total you have 1022 ways. But there is one way where nothing is illuminated. That one way also, if you take into count, 1023 ways are formed. No light, no switch you will use. That is taken. Okay, next. Question number 15. The number of ways in which 10 persons can sit around a circular table so that none of them has the same neighbors in any 2 arrangements is, first of all, it is circular permutation. So in circular permutation, the number of arrangements will be n minus 1 factorial formula. Moreover, none of them has the same neighbors in 2 arrangements. That means we are calculating only in one direction, not in both directions. Suppose A is sitting here and it has neighbors B and C. So if I count this arrangement, it is BAC. A is having the neighbors B and C. But if I count in reverse way, then A is having C and B. The neighbors are B and C. The neighbors are C and B. It is one and the same. We are counting 2 times the same neighbors. But they said none of them should come in 2 arrangements. That means you have to count in only one direction, either anti-clockwise or clockwise. So you have to take half of the total calculations. Now, there are 10 persons. So half into 10 minus 1, 9 factorial. That will be the answer. If they will not talk about directions, then you need not write 1 by 2. Only if they say same neighbors can't be included, same thing should not be side by side, all of you. Then you have to take half, remember. Okay. Next question. In the above problem, oh, they are talking about some related question. I don't have this related question with me, which they are talking about. So we will remove this question. The other part of the question is not printed. Let's take the next one. No problem. We have many questions. Here. In how many ways 10 people can be seated in a row so that a given pair is not next to each other? So, total 10 people are there. People one, person two, person three, person four, person five, person six, person seven, person eight, person nine, person 10. Among which we will take any one pair. Say we will take P3 and P6. P3 and P6 should not be next to each other, not together. But we will take together. Suppose if P3 and P6 are together, and suppose if they are total, you are seeing total, you are seeing together. After that, if you want not together, then from total, you can subtract together. That you can do it. Okay. So first there are 10 people, 10 places. So you can arrange them in 10 factorial ways. But when you take together P1, P2, P4, P5, P7, P8, P9, P10. How many people are there? These two you will count as one bundle, one person. 2, 3, 4, 5, 6, 7, 8, 9. No, Rakshita. A slight mistake. Because these 9 persons can be arranged in 9 factorial, but P3 and P6 again they can shuffle among themselves. They can arrange in 2 factorial ways. P3 can be first or P6 can be first. Arrangement. So from 10 factorial, you have to subtract 2 factorial into 9 factorial. So option B is the answer for this particular question. Let's go to next question, 18. I think at the most in one class, we are able to do 25 questions. So 4 days means 100 questions we have done. The number of ways to cut a 6-sided convex polygon whose vertices are labeled into 4 triangles using diagonal lines that do not cross is. So, first of all, it is a 6-sided polygon. Total 6 sides. And so because it is a 6-sided polygon, it will have 6 vertices. So from 6 vertices, you have to take 3 vertices and form triangles actually. 6-sided polygon whose vertices are labeled into 4 triangles using the diagonal lines. So you are using the diagonal lines. Like suppose if I draw the figure, this is the 6-sided polygon. The 6-sided polygon will have 1, 2, 3, 4, 5, 6 vertices. and A, B, C, D, E, F. They are forming diagonals. Diagonals means what? You are taking 2 points, A and B, A and C, A and D, A and E, A and F. 2 points you're selecting and forming diagonals. Again, these diagonals are taken to form triangles. That is what they are saying. So, if you take the diagonals and form triangles, or if you take vertices and form triangles, it is one and the same. I am taking A, E, F vertices, 3 vertices, and I am making the triangle. Similarly with B, you can take BA, which will be repeated, BE, BD, BC. And then you will select 3 vertices. But the diagonal lines should not cross each other. That is the condition. That means when you are making the triangle, they should not cross each other. That is what is being asked. That means how many triangles can be formed? If you take 6 vertices and form diagonals 6C2, they will be 6C2. But out of them, the sides will be repeated. AB will be repeated twice. BC will come twice. CD twice you are taking. DE twice. EF twice. AF twice. Twice you are taking. So these 6 you have to subtract. So this many diagonals you can form. So how many diagonals? Start with 6. Take 6 and 5, 2 numbers by 2 factorial minus 6. So 2 3s. And when you take 2 3s, you will have 15 minus 6. 15 minus 6 is 9. 9 diagonals are formed. For sure. But what are they saying? You have to take these 9 diagonals and form triangles. How can you form triangles? How many triangles can we form? They said 4 triangles can be formed. From 9 diagonals, you are selecting X diagonals to form 4 triangles. They already gave you. So how many? That you have to find. Is that clear? So 9 factorial by X factorial into 9 minus X factorial equal to 4. How to find X? Start with 9. 9, 8, 7, 6, 5, 4, 3, 2. Then X factorial. We don't have X. We don't know X. So X factorial I can't find. 9 minus X factorial also I can't find. But I have 4 here. That means this way will not work. First making the diagonals and then finding the triangles will not work. Directly you have to take vertices. That is why I said whether you take vertices or whether you take diagonals, it is one and the same. Taking vertices, taking diagonals is same. So directly you take vertices. Take 6 vertices. From that you select 3 vertices. That can be done in, start with 6, 5, 4. And then divide by 3 factorial. So 6 and 6 will cancel. 20 triangles will be formed. But out of 20 triangles, you have to subtract the diagonals that do not cross each other. The diagonals that do not cross each other means from 6, the 2 diagonals which cross each other, that you have to subtract. That means from 20, 6 into 5 by 2 factorial. 3. You have to subtract. And now you can find how many diagonals can be used. Anyways, this will continue in the next class. See.